It's a cold, rainy night in the year 1236 in the walled city of Córdoba, medieval Spain. Watchmen pace the battlements, shivering in the damp air, completely unaware that an army of Christian soldiers is moving through the shadows. In a single, decisive night, the capital falls, bringing centuries of Moorish rule in Córdoba to a sudden, violent end. As the map of the Iberian Peninsula shifted, city after city was conquered. Seville, Valencia, and Murcia all fell in rapid succession. But amidst this total collapse, one jewel remained defiant: Granada. Protected by its strategic height on the Acequia hill and the massive rust-colored walls of the Alhambra, it survived untouched for another 250 years. To this day, the Alhambra Palace stands as one of the most beautiful pieces of architecture ever made. But as you walk through its luxurious courtyards and intricate hallways, you start to notice something even more special: the water. It is everywhere, winding through the floors, leaping from elegant fountains, and resting in mirrors of glass-like pools. This wasn't just for beauty. It was a mind-blowing network of medieval engineering that gave the palace luxuries like underfloor heating and fountains that could literally tell the time. This incredible system kept the palace cool and brought life to the surrounding nature for hundreds of years, and it still works to this day. When the ruler of Granada commissioned the palace, the engineers faced a lethal geographical problem. The hill was around 200 meters above Granada's main river, and getting water up to the fortress would be a challenge that seemed to defy the laws of nature. The engineers followed the Darro River 6 kilometers upstream into the foothills of the Sierra Nevada mountains. They found a point that was considerably higher than the palace, dammed the river, and started redirecting it down a new channel known as the Royal Canal. With meticulous planning, it navigated its way through the difficult mountain terrain, maintaining a very shallow, precise slope until it arrived just outside the palace. But this was only the beginning. The designers had big ideas: elegant fountains shooting out jets of water, bathing rooms with pressurized showers, and clocks powered by the flow. All of this required much higher water pressure than the Royal Canal could provide on its own. To solve the pressure problem, the engineers started digging out a large storage pool in an area much higher than the palace. Below this, the water from the Royal Canal would flow into an underground pipe and collect in a well 60 meters below the pool. At the top of the well, they installed a noria, a massive water wheel equipped with buckets that was turned by an animal walking in endless circles. This would raise the water up to the surface and fill a storage pool with around 400 cubic meters of water. Having all of this water stored above the palace pressurized the entire system through simple gravity, while simultaneously giving the palace a backup supply in times of drought. From here, the water passed over a massive aqueduct and into the palace, where the technology starts to get really interesting. The water would split off into a complex network of carefully designed channels, carrying just the right amount of flow to the pools and fountains, the most impressive of which was located at the heart of the palace, the Court of the Lions. Built in the 14th century, it featured 12 lions that each shot out a jet of water to show what time of day it was. In a controlled sequence, the lions would activate hour by hour until all of them were spouting water by midday. The system would then reset itself and the process would start again. But how was this possible with medieval technology? The engineers used a simple but brilliant design. The large bowl at the center had 12 holes placed at very specific heights, each leading to a different lion via internal pipes. A central pipe filled the bowl at a slow and constant rate. As the water level rose, it hit the holes one by one. The heights were so precisely calculated that it would take exactly 1 hour to reach the next hole. To reset the clock, they used a natural siphon. As the water reached the 12th hour, it filled a curved drainage pipe. Once the pipe was full, it created a vacuum seal, and the surface tension of the falling water would pull the rest of the bowl's contents out in a matter of seconds. The bowl would drain completely, and the 12-hour cycle would begin again. The water continued its journey throughout the palace, eventually reaching another engineering marvel: the thermal baths. This is where kings and diplomats would come to relax and make deals. It featured a cold plunge pool, a hot room with heated flooring, and a steam room. The water would enter a control room underground and pass through a copper boiler heated by burning wood. From here, the hot water would flow through pipes to various fountains and showers. To provide underfloor heating in the hot room, the steam from the boiler was directed through channels underneath the marble floor. The steam would then travel up through hollow pillars and exit through small, star-shaped vents in the roof, which could be opened or closed to control the level of vapor and heat. As the water continued through the network, it provided one more benefit: cooling. Granada is an extremely hot part of Spain, but as the warm air blew over the palace's many pools and fountains, the water would evaporate. This process naturally stripped the heat from the air, turning the Alhambra into a cool, comfortable sanctuary, even in the height of summer. The final challenge was the western portion of the palace, where the soldiers lived. This area was built 6 meters higher than the rest of the palace, meaning the water had to make a final climb. For this section, the engineers came up with something even more impressive than a water wheel. They created a device that required no animals and no external power. Water from the system would flow into a container with a hole in the bottom leading to another container below. As the water traveled down the pipe, a whirlpool would form in the top container. At the center of that whirlpool, a low-pressure area formed, sucking air downwards into the pipe. In the lower container, the air and water would mix, creating gassy water filled with bubbles. Now, because this gassy water was much lighter than the solid water in the supply pipe, the pressure from the incoming flow was able to push the lighter mixture 6 meters straight up the hill. By passing a constant flow through the whirlpool, this device raised water higher than the point it entered, providing for the rest of the palace. Today, many of the clever water systems around the Alhambra still work. They stand as a lasting tribute to the incredible engineers who hundreds of years ago mastered the physics of the earth to turn a dry mountain ridge into a living paradise. Thank you for watching this journey through the hidden marvels of the past. The world is full of these forgotten masterpieces of history and science, waiting to be rediscovered. If you enjoyed uncovering the secrets of the Alhambra, don't forget to follow and show your appreciation. It helps us bring more of these incredible stories to life. We want to hear from you. What historical mystery or engineering wonder would you like to explore next? Let us know in the comments below. See you in the next video.